Hello everyone, and let us explore experiment called as decision trees. Now, when you have some data, you can arrange that data in a hierarchical format where you will start with the root node and then you will be ending up with the leaf nodes. So this is the basic concept of tree. So let us try to apply this decision tree algorithm for a simple data set called as salaries.csv. You have to make sure that that particular data set is available in the cloud platform. So just you have to make sure that you are logged in to the Google Colab and you are connected with the cloud server. Currently it is getting connected. So once it gets connected, you are able to view what different files are here. I could not find that salaries file which is been used. So make sure that that file is in uploaded. So I'm importing that particular file. So this is the experiment related to decision tree. So this is the salaries file I'm importing. So the file is now available to the cloud server. So as we are dealing with these data structures of kind a data frame. We are importing these pandas here, pandas library, and then with this import of pandas we could directly read a csv file. So the salaries.csv file is read into the df as a data frame. So if you want to view this, just let me show you. This is the file available where you're having the attributes like the company, job, and degree. And one most important attribute which is available is the salary is more than 100K or not. Maybe these are the different employees working in different companies with the different job title, and this is their educational qualification, and this is the data available to me about whether that person is having the salary more than 100K or not. So this is the data available to us, and from this data we will form a decision tree, and then we will implement this decision tree for the classification, where if suppose some new instance is given, so it will predict whether that person should get a salary greater than 100K, or the salary should be, or salary may be less than 100K. So we have imported these pandas. Now I'm just reading this csv file. So this file is now available, and then you could see the different values here in the file. So in the for the first transaction id, not transaction id, for the maybe for the first person working in Google, he is working as a, he or she is working as a sales executive, a bachelor's degree, but the salary is less than 100K. While someone is here working in the Google itself, working as a business manager, and bachelor's degree he is having, but still his post is business manager probably, and because of that the salary is more than 100K. So that's why it is coming as here as one. So now let us use this data to form a decision tree, and let us use that decision tree to make a decision or to classify some new instance. So whether that particular person will get a salary or greater than 100K or not. Fine. So you read this, and now this is the data. So if you look at this data, it's a nominal data. Nominal data cannot be processed directly, right? So what we have to do is we have to convert this nominal data into quantitative data or numerical data. So let us see how this can be done. So out of these data values, so these are the three attributes which we will be consider as the input, and then output will be whether the salary is greater than 100K or not. So let us create that. So input, what we are doing is, ये जो data frame है, we are dropping the salary more than 100K attributes. When this particular column we are dropping, so what remains is these three columns. So these three columns will be forming the input, and then the last column will be working as a target now. So this is how we have separated the data into the input vectors and the target values. So now once you have this, as we know this is a nominal data, we have to convert it into the quantitative data. So the encoding is done. So label encoder is used here to do that encoding, where the attributes which are company, job and degree are converted into company n, job n and degree n. See what result we are getting here is, if you are looking at these are the values, company is Google, so there are means Google company is assigned as 2, then company ABC Pharma is 0 and Facebook is 1. So there are three different companies, so they are assigned numbers 0, 1 and 2. Like that for the job levels. So if you're looking at job levels, again there are three types of jobs. So one is business manager, another type of job is computer programming programmer, and third one is sales executive. Again these are converted into 0, 1 and 2. So this is the nominal data which is converted into the numerical data, quantitative data 0, 1, 2, and same thing is done for the degree. And degree, if you look at, only two values are there, either the candidate is having bachelor's degree or master's degree. So this is converted into 0 and 1. So this is how you are having, this is the nominal data, and by using the encoder which is mentioned here, label encoder, this is converted into the numerical data. So now this is the data available. So now we are inputs, I'm considering again as I'm dropping this input n means inputs dot drop company, job and degree. So these are the inputs. So if you look at input n, so new values are the company attribute, job attribute and degree attribute represented in the form of 0, 1 and 2 values here. So this is the input. On the similar lines, on very similar lines, what we can do is we can have this target also represented. Means if the salary is less than 100k, it is 0. If it is greater than 100k, it is 1. Right. So this is the target value, and now what we are doing is, here is how the learning now taking place. So scikit-learn, from the library we are importing the decision tree, and then decision tree we are using as a classifier. So we are using this as a classifier, and input values are considered as the input, and then we are generating a machine learning model by mentioning the inputs and corresponding target over here. So here a decision tree is formed here, and then when this decision tree is formed, so we can evaluate the performance of this decision tree. Here the performance is 100%. Now what I'm doing is I'm checking how it is performing. So what I'm doing is I'm saying that model dot predict, I'm trying to predict if my inputs are 211. So now 211 means what? 211 is this particular combination, means transaction number 5. So 5 means Google computer programmer and masters, Google computer programmer and masters. Now I'm trying to predict whether that will get that particular person, that type of person will get a salary greater than 100k or not. So you know that actually database is saying that yes, that person should have salary greater than 100k. Now what is happening here is, if I'm giving this as the input 211, and then let me run this, and then what I'm getting is the prediction is made as 1. Now let us make it 0 here. This 0 indicates that the bachelor's degree is there. So let us check if the bachelor's degree is there. This value is 0, indicating that the salary should be less than 100k. This is the prediction what we are making. So this is how, once you have developed a decision tree as a classifier, now you can apply different inputs, and then you can check what is the prediction of the result, and then again by looking at that particular prediction, you can talk about what is the performance of the algorithm also. So this is what is the implementation of the decision tree as a classifier for a data set which is mentioned as salaries.csv. The aim is to predict whether develop a decision tree so that it will be predicting, given the attribute values, the company, job and degree, it will predict whether that person have salary greater than 100k or not. So this is all about the experiment number 10, decision trees. Thank you.